Hello, everybody. Welcome to OpenCV Live. And today we have with us the CEO of Roboflow, Joseph Nelson. And Roboflow has been our supporter for many years now. And they have the same philosophy as us. We share the same philosophy of creating tutorials and tools for users that are very easy to use. And I'm very glad to know recently that Roboflow has come up with this idea of workflows. Now, when you create any CV application, it is not just one model. Usually it is a combination of models. You can even use LLM sometimes. You need OpenCV sometimes. So you can have one CV model, two CV models, or sometimes a combination of these models and workflows and different kinds of pre-processing, post-processing, etc. And so to build a CV application, you need a pipeline of tools. And Roboflow has come up with this idea called workflows, which basically ties this all together. And today we are going to learn about that new feature in Roboflow. I'm so excited about this. Joseph, welcome to the show. Give us a short introduction. But before that, I will have to acknowledge our the producer of the show, Phil Nelson. The two Nelsons are not related, apparently, not even from the same area. So Phil is the director of content and creative at OpenCV.org, and he produces the show. Anything that goes wrong is his fault. Hi, Phil.
Yes, that's right. Acknowledge me. I am your tribal chief. I'm also your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you, my dear friends, can call me Phil. And I'm here to remind you of a few things we do on every single episode of OpenCV Live, the show you're currently watching with your eyeballs, probably. One of the things we do is give away something to you in the audience. Later on in the episode, I will be asking a trivia question based on the presentation from our illustrious guest, and the first person to answer that question correctly will win the OpenCV course of their choosing. You can go to opencv.org/university to see what courses are available, and even if you don't win today, maybe get a course for yourself, upskill, get a new job, get paid more at your current job, make more fun, interesting stuff. We're also taking questions from you in the audience, so please use the Zoom Q&A button at the bottom of the screen there if you're in Zoom, or just use the chat system wherever you're watching. We are live on YouTube, Twitch, Facebook, Zoom, and LinkedIn Live. So just use the chat system there to ask your question. I will be monitoring those and doing my best to answer the questions as they come in. Before we get started, however, let's do some brief talking about OpenCV and why we are here, the reason for the season, as it were. OpenCV is a nonprofit organization that runs an open source library that you don't ever have to pay to use. Many people have called us foolish for doing this. Sometimes we agree with them. But we have been so lucky to have, in the last couple of years, built a really strong membership and partnership program, and Roboflow was one of the very first ones to join that, and so we're super happy to have them here today. Sati, do you want to briefly talk a little bit about OpenCV and why it's so important to support us, and a couple of the ways that folks can?
Well, yes, OpenCV is the library that powered the first autonomous vehicle called Stanley that completed 132 miles in the Mojave Desert to win the DARPA Grand Challenge. And it's used widely today, 20 million times a week. And, it's in helicopters that go to Mars. It's in pretty much everybody uses OpenCV. And so it's very important to support it through donations by the community, because even though we get donations from large organizations, it's not sufficient. It is because this is a huge library to maintain about 2,500 different algorithms, and to come up with new versions frequently, it takes a lot of effort. So that is why we ask you, the community members, to help out. And if you personally donate, that's great. But if you can get your organization to donate and become a silver member, gold member, or a bronze member, that would be awesome too.
Yes, so you can go to opencv.org/support to find out various ways to support OpenCV, including individual donations, how to become a member organization, along with pamphlets that tell you the benefits and perks that gold silver, and bronze member receive, as well as finding out how to sponsor OpenCV on GitHub, another way you can support us. We actually lost one from last week. My heart is broken. We're at 9 current sponsors. Thanks so much for everybody sponsoring us on GitHub. You can check that out by going to github.com/sponsors/OpenCV. And if you work for any of the organizations that use a system called Benevity to do match donations or vote on things to donate to as part of your organization, such as Starbucks, UPS, GE, Levi's, John Deere, Facebook, I believe Google and Microsoft all also use this platform. If you work for any of those big heavy hitters, you can go there, search for OpenCV or the Open Source Vision Foundation. And if your organization does matching donations, you can donate to us there and your company will match your donation, which is pretty sweet. If you got a few bucks, go check it out. OpenCV has got an official YouTube channel. We are at OpenCV Official on YouTube, 58.1K subs on there. Thank you so much as we march toward the 100K subs plaque. Do we still get a plaque for that? I'm pretty sure we do. That'll be pretty sick. Can I have that one? You've already got one. Satya's already got one.
Yeah, I have it somewhere. I should put it on my...
You got to have it in the background, man. What's the point?
That's right. That's right. I have it somewhere here.
It's like having a Honda without the badge on it. How do people know it's a Honda? There's a little
Right
Simpsons
there,
joke
right
for
there,
people
see?
up there. Yeah, beautiful. Look at this. Yeah, the man. So go check us out on YouTube so we too can get one of those sweet 100K sub badges. OpenCV is also on LinkedIn. We've got over 300,000 followers on LinkedIn, which is extremely awesome and somehow surprising to me, despite the fact that I did all of that. I'm the one that posts all that stuff and interacts with you on LinkedIn. So thanks so much, everybody, for the incredible following on LinkedIn. 200K subs on the LinkedIn newsletter as well. And we got one more thing to talk about before we get started, which is our friends at 7 Cents. Big press release. I don't know if you got the chance to read this, Satya. I know where you were flying. There's a new project from 7 Cents called SenseCrypt. This is essentially, well, they really did a great job of getting all the buzzwords in the second line here. A groundbreaking technology integrates post-quantum cryptography and SSL security for the next generation of face-based EID solutions and face-protected digital public key infrastructure, or DPKI. You can go check this out. This press release came out a couple of days ago. This is really fascinating stuff. Essentially, they've figured out a method, a system to do offline verification with just your face without the verifier actually needing any of your personal information or biometric data, which is very interesting today, especially as cameras become more ubiquitous, AI gets more ubiquitous, it's easier and easier to scan people's faces, but a lot of the ways we're using that stuff is pretty dangerous and bad overall for not just society, but the way the technology is being built, I feel personally. And this is an interesting way around that. If you never have to share the biometrics, that cuts off one potential issue of, a leak. Like we get all these leaks of everybody's social security number, everybody's phone number, et cetera, et cetera. So pretty interesting stuff. We'll be talking more about this later in a webinar. I just talked to these folks yesterday, so I thought I would bring it to you all. Any quick thoughts on this after seeing it, Doc?
Yeah, no, I just came to know when I was traveling, and this is I mean, I agree that this is a lot of buzzwords, but this company 7 Cents, they are at the cutting edge of anything related to Face ID, face recognition. And it is
top
also
10 NIST.
Amazing company, right? And the funny thing is that Varun, who is one of the founders, he started like 7 or 8 years back in computer vision, and he actually took one of our courses in the beginning, and now he is at the cutting edge of computer vision and doing exceptional work. 7 Cents, I have such big hopes for this company because the kinds of, when we first did this, worked with 7 Cents, they came to us and they said that we have the solution. Would you like to partner? And I said, I took out my ID card because I knew that it is very difficult to match ID photos. And it was very low light. And I said, if it matches, then we have a deal, right? So he took a picture of me and it matched with my ID with a very high level of accuracy, something like 95% confidence. So then we started talking with them and kicked their tires and things like that. So amazing.
Pretty cool. Yeah, definitely. Also a great group of people, and Varun very generous personally to OpenCV during our last campaign. So thanks so much. We really do appreciate it. Having said all of that, I think we are ready to go.
All right. All right. Now we are ready for Joseph. Thank you so much for coming again. And I'm a fan of Roboflow, but also I'm a fan of your presentations, the way you explain things. It is exceptionally well done all the time, and so I'm very excited to learn about workflows today. So Joseph, please start with an introduction, and then we'll go over the presentation you have and the demos.
Yeah, welcome, Joseph.
Thanks all. Great to be here again. Thanks so much for having me. OpenCV every single time has amazing new progress of both supporting the community in general, other ways by which you're uplifting other sorts of projects. So we're thrilled to be early backers of the efforts that you've made to engage the community and continue to support a lot of the efforts, both in the GitHub sponsorship you've opened up, plus being OpenCV Silver partners, as you mentioned. In fact, some of what we'll discuss today is some of the ways by which folks can build with OpenCV even easier, like template matching and other capabilities, and using those capabilities in tandem with machine learning-based approaches and even multimodal approaches. I'll give you a bit of background on Roboflow for folks that may be unfamiliar. And there's many new things that have come in the computer vision ecosystem that I know we commonly like to touch on, topics, trends, and things that are new, and then would love to move some of the discussion into what we've been working on with enabling folks to make it even easier to stitch together models, accomplish multiple tasks, and even kind of build visual agents for understanding context from images and video. I'm Joseph. I'm one of the founders at Roboflow. And for those that may be unfamiliar, Roboflow exists to make the world programmable. We enable software to have the sense of sight. And the way by which we do that is we build tools, a platform, and community for developers, enterprises, and teams to use computer vision in production. A lot of our tools focus on the things that you need to get value out of computer vision. So typically things like understanding data sets, automating annotation, validating that you're getting the right samples, ensuring models are performing the way you want them to on your data, all things data set understanding, management, collection, aggregation. We have tools focused on model training and evaluation, training models, and whether that's object detection tasks, instance segmentation, increasingly multimodal capabilities becoming supported, key point detection, traditional classification, and evaluation of those techniques. So doing embeddings-based understanding to see where there's patterns of model failure, and link back into improving data set and model results. And then in deployment, and this is a place where we've spent quite a bit of effort. We have an open source inference server that enables hundreds of millions of calls, plus video streams and processes to be run every single week, let alone each month and each year. It's actually the infrastructure that Roboflow internally is built on that we've open sourced for anyone else to build upon too. So it's kind of gotten battle tested in a lot of different contexts. And as a part of deployment, you can run on your cloud, on the Roboflow cloud, on the edge. And we're increasingly investing in capabilities related to chaining together multiple models, because that enables and extends the types of tasks that become possible and able. So that's some of what we'll speak about in greater depth today. In sum, I mean, thanks to the community more than anything, Roboflow now has a little over 500,000 folks building with the tool, a little over 500,000. The Roboflow universe, which is the open source collection of projects that the community is building and sharing, includes 400 million user annotated and shared images across a wide array of topics. That could be aerial imagery, it could be underwater images, thermal images, document processing, agricultural imagery, cells, everything in between. And that continues to be a useful hub as users share with other users the ability to kind of bootstrap and understand and make the world be visually understood together as we're all on this journey of advancing senses of visual understanding. And on the commercial side, we've been proud to continue to accelerate both in adoption from the free plan that we have and always will to the starter plan that's best suited for companies that are embarking on their computer vision journey, typically startups and teams inside of larger companies and enterprises that are increasingly relying on driving operational improvements. And that can be companies as large as Walmart or John Deere or Rivian, and as small as the hundreds of startups that we're proud to partner with every single day. So Roboflow is in a fortunate position largely because of the community and continuing to build with and for others. And one of the things that I'm excited to share today is all of the open source work. A lot of what we're about to show is all built on open source infrastructure. So everything that we make, showcase, and build is able to be tinkered, pulled apart, extended, integrated, self-hosted, you name it. And so I look forward to walking through some of the capabilities of what's possible. But that's a bit about Roboflow. I'm eager to both maybe have discussion about some of the new models that have come out, both on the multimodal side, like QuenVL, GPT-4o, SAM2, and then maybe get specific and show some examples of how to use those models in given pipelines in production today.
So one question I have is, the workflows that you have created, I haven't got a chance to look at it yet, but would you call them like agents? The new word that is the buzzword that is floating around, agentic AI, would you call them agents, or they are different models strung together?
Kind of depends on what someone may want to consider the syntax of the term and of the flavor of the day. Ultimately, what a workflow is the ability to chain together multiple steps that could include everything from pre-processing and image capture to model inference, multiple model inference to writing to some system. Now, what's interesting, and the reason I actually described it in some ways as a way to build agents, is that's actually what users said to us. They're like, hey, I've been using this thing, and I've been basically, for example, like one of the ones that at the office in San Francisco, or package theft is something that can occur. And so like one example of one thing that users have built is you have an RTSP stream coming from like a Unify camera that's just seeing the view outside the office. Right. And you have a first model that's running, like a smaller object detection model that's running on that feed in real time at 10-ish frames per second. When it sees a package, then it crops to that package area, and then it passes that crop to a larger model, a foundation model. And if you want to self-host, it could be an open source foundation model like Florence 2 or Cog VLM. If you can use an API, you can use like GPT-4v or Claude or Gemini. And you can ask and say, hey, tell me everything you can about this package. Is it a flat pack? Is it in a box? If you can see the label, tell me who the label's from. Multimodal models are pretty good at doing OCR. And so then I have the output from the big model, and then I can pipe that output back into another set of systems and be like self-referential, which is kind of where I think folks get the agentic viewpoint. Right. And you can also pipe that to like Twilio and say, hey, send me a text. And so in some, I can declare this chain of thought, which is saying, monitor this feed with a cheap, small edge model that can run in real time for low cost at high frame rate. Then when you see something of interest, hit this larger thing. Then when we have this larger thing, send it to another system, which might be like Twilio to text me. And then in total, I kind of have this like this worker. And so like, we'll show some examples, of course, here in a moment, but that way of constructing that chain of thought, I kind of think about that like, it's like, I don't know, workflow is a easy way to conceptualize what that is. And what users kind of played back to us is they're like, I'm actually building visual agents. I'm building independent processes for visual understanding, which I think is actually a fair way to characterize it. We generally say, it's a way for very rapidly pulling together multiple models and extensively creating a almost workflow or a pattern or a template or a operation, any of those kind of interchangeable. Increasingly, I think folks think of these as visual agents, which I don't think is inaccurate by some definitions, but we've kind of been told that more than been like, hey, this is like the agentic builder. It's kind of been exciting that the community has described it this way.
Right, right. Yeah, I mean, a demo would make it extremely clear, right, how things are put together.
Awesome. I have a few different workflows that I think will be fun to show off. And the fun thing is a lot of these, when you build a given workflow, you can actually make it be like publicly shareable. So I can actually share some of these workflows directly in the chat. So I'm going to have folks kind of like build along with us of some workflows that we can make. The very first one that I think would be fun to share is actually not a workflow that doesn't use any machine learning, but is only traditional CV. So built on OpenCV blocks. So why don't I screen share and you can validate for me that works.
Looks good.
So very, very simple here. We're going to have an input image, and then we're going to do template matching, which, as you know, is going to take the outlines of what pixels look like in one image and compare them to find that pattern of pixels without using machine learning, just using the, in this case, we're going to use SIFT in OpenCV. Then we're going to visualize those as bounding boxes, and we're going to provide those as outputs. I'm just in the embed viewpoint, which means that like this URL is actually publicly shareable. So I'll drop it in the chat for folks that may want to follow on directly. And then I'll fork it and work with it directly in my space. But just for the sake of doing a quick preview, the template that we're going to match, this is for you, Phil. We're going to do a Super Mario coin counter. So we have the template we're passing, which is the Super Mario coin, and we're going to pass it to this image. And so I'm going to select that as my inputs and just very quickly kind of run the outputs. And I get the JSON predictions of where it sees everything. But even more importantly, I can do show visual. And boom, with the bounding box visualizer, I'm seeing, hey,
very nice.
Look for this template in here. Now, let me click use this workflow and kind of fork it directly, because then we can actually get under the hood and mess with it a bit more.
Right. So for people who are new to computer vision, template matching, just to set the expectations, it needs to look almost exactly like the template itself, right? So it's not like a object detector where you can give an object of a dog, like a template as a dog, and it will find all the dogs, right? So template matching means that the template has to be very close in appearance to the ones in the picture, like this example.
I just dropped the link to this demo in the chat.
Oh, thank you, Phil. So yeah, this is a very, very, very simple one, right? Where with the template matching block, it expects an input image, right? It expects an input image, and it expects a template image. And so in the input, we declare that we're going to be expecting an image. That's the client defined here. And then we said that we're going to expect a template, which is going to be defined here. So input is going to pass an image, going to pass a template. Template matching block is going to use the image, and it's going to use the template. Now that's going to return where it sees matches. And so we want to visualize those matches. So now with the bounding box visualizer block, we are going to accept the quote unquote predictions from the template matching. And we're going to also use the input image. Then in the response, we're going to display we're going to call it template matching, and we're going to display the outputs of our template matching with our bounding box visualizer. And that's it. That's all the simplicity of this one example is. So that's like a very kind of straightforward way. I thought it might be fun for us to actually maybe build the next one together as an example. And then I can showcase a bunch of other ones. But to set the stage here, so inside Roboflow, as I think folks are likely aware, it's kind of like the set primitives you need to go from image to inference. And sometimes you need to start with your own data set, because maybe large models and existing models don't know your data well. And that means you need to curate your data set and understand it, train a model and deploy that model. At some step, though, you get to this spot where you have a model that works, but there's more context needed than just like a model. You want to have input to the model. You want a system that, okay, the model's going to run, and then I want to output that model's results to some other thing. So that's kind of where workflows fit in. It's kind of like, okay, great, I've got a model that works, but I need to connect it to the rest of my systems.
Right.
But just for a quick, like, how did we get here sort of thing? I thought it might be cool to show, let's pretend like I had to train a custom model, and in this case, maybe I needed to identify where Rick Astley is at because I need to keep him off my screen. And so, for example, this is where, we can do label-assisted capabilities. We actually have SAM2 integrated, segment anything 2.
Oh, nice.
Which does
Oh,
real-time visualization.
I love that. Yeah, we all of the king's horses and all the king's men, the brightest minds in the world, and we've successfully created a Rick Astley segmenter.
The world needs it. The world needs it. So this is in fact that is Rick. That is Rick. And this back here.
This is also science fiction to me because for people who grew up with trying to create segmentation algorithms, etc.
Yeah, 10, 15 years ago.
On a browser, right? So SAM2 is amazing. It just feels like science fiction to me even now.
Yeah, it kind of reminds me of the Dire Straits music video for Money for Nothing as well. There's one for the 40 and 50-year-olds out there.
So now this is just for like data preparation, right? So like, okay, great. I've got that's using SAM for data preparation. And then maybe I have my full data set here and I'd want to split that out by maybe we can show all the places where we found Rick in the maybe the training set. Oh, this is me holding Rick up on a music video on my iPhone. That is indeed Rick. And then great, I can also, of course, better understand everything that's going on inside my data set with dataset analytics. I can generate a dataset version, and then I can have a trained model that I can actually, try out in real time. And here, let's see if this works nicely with Zoom on the screen share. What this is going to do is open up a web page, load the model to run in the browser. And hopefully this is screen sharing. You should be able to see.
You see it.
Okay, great. So this is running that.
You are confirmed, not Rick.
I am confirmed, not Rick. Mark safe. So I this is running.
Mark safe from Rick Astley.
That's of course like a quick way to prototype a model, but I could also deploy this thing, to Luxonis Oak, to Webcam, just as I did, to a Jetson. I could visualize, the model's capabilities and find other folks that hopefully are not Rick. Yep, great. Does great. Oh, this one, it's a little less sure. If we adjust the confidence down, yeah, we need some more representation of folks against brick walls, it looks like. Yep, that looks like that's not Rick there. Anyway, so great.
Very
so
unlikely to be Rick.
Could be Rick. So then I get to the step where it's like, great, okay, I've got my model, but now I want to like deploy that model, right? And I want to like visualize it and I want to run it places and maybe I want to do active learning with it. So that's where it's really useful to drop into building a workflow. So for example, I could even just build a workflow that here I will do, maybe we could just do the Rick model, what did I call that? I call that never gonna. So maybe my never gonna one model. So cool, I've got my never gonna one model. And then I'll also do like a quick bounding box visualizer. Okay, great. And then I'll need an example image. Phil, I'm gonna screenshot your Zoom link, smile big. That's great. Let's
try to do my best Homer Simpson, no thoughts face.
Great. So I just screenshotted Phil and we get the JSON here of what the model predicted. And I can also show the visual.
No thoughts, only pro wrestling.
That's great. That's great. And you know what? It looks like I actually want to add the label visualizer in addition to the bounding box visualizer. So I'll add label visualizer. Yeah, great. So now I'm going to have an image come in, going to run a model, bounding box, label. Okay, cool. Let's run that preview again. And so now I should both get the visualization of the model and a boom and a not Rick. That's as clear as it gets.
Confirmed, not Rick.
Now, critically,
I'm tired of all these rumors that have been dogging me my entire career. Finally, vindication. Complete vindication.
I
The
love the
AI
bat.
has spoken.
I love the bat in the background too. So this is a relatively, kind of straightforward example, but we're going to build to more complexity here. Before we build to more complexity, I do want to note that this workflow, so we mentioned that this is fully open source. The builder, the UI is, built on top of inference, which I could then take and pull down and run and hit the hosted API with the inference SDK with my given API key. I could run it fully locally, meaning I could pull down the inference server. And if you're unfamiliar, inference is just this project here, where I have the ability to take hosts and run on edge devices. And I could do inference server start, run on local host. It starts on port 9001. It's over 9,000. And then I could call the model that I want to run, custom workflow, and then my image. What's really nice about this is if I change my workflow, my endpoint stays the same. So if I have something deployed like way out on a device somewhere in the field or in my application, I could improve the model or improve visualization, and the endpoint would remain consistent. And the last thing is I can run this thing on video too. So we did the webcam example, but I could also run this fully on what we call inference pipeline, where I pass a feed of videos, which could be an RTSP feed or something like a video to run asynchronously, some max FPS if I want to set it, and away I could go. So, okay, great. So I've got a very, very simple initial workflow builder that I could take and deploy, but none of this is super groundbreaking yet, and we're going to build up to complexity, but now we have the core kind of primitives. And yes, I could run this on a Jetson. I could run this on my own cloud. I could run this, on the hosted URL, which I'm doing for these previews, of course, are just hitting a hosted URL. Now, I say we maybe dial up the complexity a little bit. So let's I'll save this as my Rick Finder. That's my Rick Finder workflow. And you know what? Why don't I give this to the audience? You all can see, are you Rick or not Rick? So I will,
Yes.
so this copy embed code here, if I do the copy embed code and then I open it in a new tab, copy shareable URL, and I open in a new tab, the embed code would be if I wanted to like iframe it. The shareable URL is like this, which is viewable without any logged in experience. And I could do a preview, I could run it as is, and I could drop this exact workflow into the chat for everyone to figure out, are you Rick or not Rick? So
I love one of the things I love most about Roboflow is how low friction you make this stuff. Like you're not locking everything up behind like a sign up and an email verification and blah, blah, blah. Like people can just like get their hands dirty really easily, and that kicks ass.
Yeah.
Appreciate that. Yeah. So this workflow, right? So when you build a cool workflow, people often want to brag and show off what they've made. And hint, hint, there might be some prizes coming soon for cool workflows that people build in a certain Hacktober month. But the workflow that I made here, any workflow that I make could be run on any given image, and then I could fork it and run it, and the compute's included, and away you go. So that's the link I just put in the chat. But I just described a few simple workflows. I kind of want to, as I mentioned, maybe dial up the complexity and talk about a workflow that's a bit maybe higher steps, but also a bit maybe more utility. So what do you say? Maybe we do that together.
Yeah.
So the workflow that I next want to make is I'm just going to use a public model, the Coco model. And as folks are familiar, Coco.
You sure use Coco a lot for a guy that likes to talk shit about Coco.
Hey, Coco is great. I like how I've been branded. You know what? I'm gonna start building. So let the haters hate and just keep building, right?
That's true.
So okay, so I'm gonna add an object detection model, and this time I'm gonna do a public model. In the public model, I'm gonna do is I'm just gonna do YOLO V8 N640, which is defaults to Coco. And then just like last time, I'm going to add the bounding box visualizer. And then let's also add a label visualizer. Okay, great. So now this is just a simple Cocoa model. But let's run this on, I have this parking lot image, which I'll run preview of my parking lot image. And I mean, Cocoa does its best, right? These cars are far away.
Right.
There's lots of people, and we know Cocoa has a people class. So it's doing its best.
Yeah.
We can thank it for doing its best. But we know that, with small objects, Cocoa sometimes struggles. So this is sort of the setup here is we've got a very simple input, running a Cocoa model, bounding box visualizer, label visualizer, and this is what it looks like just off the shelf for a small version of Cocoa. Now, I think that, I don't know about you all, but I think that we could actually get a lot of value by using techniques like SAHI, which is a way to slice up images into smaller images. And in fact, SAHI is built into this already. So I'm going to add a slicer block, okay? And
I
then
also like that you're not using the technical names. You're using I
Or
like
colloquial. They're colloquialisms.
yeah, I mean, image slicer is much better, right? I mean, because people may not know. That is one challenge I have with OpenCV. When we started, it was for a very technical audience. And so all the names are, they are very technical, like canny edge detection and not just edge detection, right? And then you have, so those kinds of things, right? I really like that you went for people who may not even be from a computer vision background, right? They would know what to do. The blocks, these blocks are very, the names of the blocks are very
They're
nicely
descriptive. They're descriptive,
and
evocative,
right.
if you will.
Yeah, you would know what they do by looking at the name.
I appreciate that. It is a little bit of a challenge of like, how do you make it be simple enough, but yet powerful enough to be well understood?
But there's a reason that it's still, kind of, it's basically universally accepted that naming things is the hardest part of computers. Like nobody will really argue with you. They're like, yeah, pretty much.
Let's do
The
texture.
first company I started, we named it Taz, T-A-A-Z. I have never regretted. It was the worst name ever. People couldn't spell it.
Did Warner Brothers come after you for that one?
No, you mean the Tasmanian devil?
Yes, the
No, they
Tasmanian
don't.
devil,
They
Taz.
didn't. Yeah.
That's why there was a pro wrestler, T-A-Z-Z.
Oh,
So he
so
had the
that
two Z's. Yeah, that was how they got around.
we considered both of those, and we thought that, okay, should we have that problem? It would be a good one to resolve, right?
Yes.
Okay, so let me kind of describe what I've started to cook up here. So what I wanted to do, what I wanted to remember is I wanted to just run my first model through, and we have Cocoa, which is just default Cocoa running on the top. But what I want to do is, in fact, if you take a large image and you break into smaller pieces, and then you run an object detection model on it, and then you stitch together back the outputs of that model, and then we're going to do the same visualized steps, you often see a lot higher quality images that are possible. And so that's exactly what we've done here now is I've taken my input image, and then I'm going to have, so we still have the same branch of, hey, Cocoa just doing Cocoa things. And then I have on the top one here, I've added the ability to do slice it up, right? So the image is going to come in and it's going to get sliced up. Then I'm going to do object detection. And then I'm going to do stitch those together, and then I'm going to visualize. And I've gone to the preview mode because I'm going to drop this one into the chat in a moment. And so if I run preview on this, we should see the result of first the Cocoa model running without being stitched together, and then being stitched together. So the top one is what we saw before. And now the bottom one, running inference slicer.
Dang.
All of these differences. And so you can imagine, of course, anyone could take and use this workflow. So I'm going to copy this embed link. And if you have the same problem where you want to detect small objects, you could swap out Coco, of course, with your own model. And again, the same benefits that we described that we had earlier. So I just clicked use workflow just to give an example, and this is going to put it directly into my space.
Wow.
And now
This, just to give people an idea, even if you knew the entire pipeline, right? If you're an expert, it would take you an hour to just maybe more, right? To just
Even
set
if
up.
you were using like Chat GPT to generate boilerplate, it would still probably take at least an hour.
Yeah, but for most people, right, it would take several hours to accomplish what was done in just a few minutes. And I'm guessing that even if you did not know Roboflow, if you had to think about this and come up with, it would take you tens of minutes, right? It won't take you multiple hours to figure this pipeline out. So
Very cool.
especially because all the tutorials and examples are available, and that makes it even easier. So this is very, very impressive. This is very impressive.
And the goal
Absolutely.
here is that, while we have kind of like the visual builder, again, all of this is extensible as code itself. In fact, I can even connect. Someone asked, like, how long does this take to run on inference? And as everyone knows, inference is dependent upon the machine that you connect to. So right now, I'm just using default publicly available infrastructure that's hosted on detect.roboflow. But I could deploy this on a dedicated deployment, or I could deploy this on localhost. Or I could deploy this in maybe if I had my own inference server running that I wanted to connect to the server URL, my own port, I could do that here. And so
when you deploy this on localhost, it is the model actually running on your local host, or is it still communicating with the Roboflow? No. Oh,
running
okay.
locally. And that's because what's happening when you pip install inference and then you start inference locally, you're actually running this package, which comes with the inference server. And in the inference server, it comes with a registry of models that users can just use out of the box.
Okay. What about large models? Let's say if you're using a very large model that gets downloaded?
If you're using an open source large model, yes. If you're using large models that call an API, then the local server would call the API just like the web would. So for example, if I added a GPT block that is going to do, hey, explain what you see in this image.
Right.
That of course calls an API regardless of the local client's calling the API or if the cloud is calling.
What about something like Llama, where you have the option of running, at least 70 billion one you could run locally, but you may also have a hosted version of it. Is it possible to connect to a hosted version of that?
Yes.
Okay.
So the for a lot of what we see is folks will run like if you have like the package example, you may run the object detector fully at the edge, and then only when it sees a moment of interest.
Right.
You can do a machine learning based way of like, hey, I object detected something, or you can even do a rule based way with OpenCV of just doing movement detection. And then if I see that, then I'll trigger and send to a cloud that frame or sequence of the next 5 frames.
Right. One other question that this is so good. Is there a way to actually just write in plain text, right? I want to build an OCR, something like that, right? An OCR model, right? And which does such and such things, maybe, and this graph is outputted. Is that possible?
Soon. So let me give you.
All right.
Let me give you some
That's the
context.
holy grail.
Yeah. So all of this workflow here is definable as JSON, right? So I open the JSON editor on the left, and this JSON is declaring which nodes exist.
Oh, wow.
And this JSON is what's being passed to the inference server. And the inference server is then knowing what order things were written in.
Yeah.
And the inference server under the hood, by the way, makes a number of optimizations to use compute efficiently. So for example, like in a case like this, where I have a model that's being run in parallel, like I have object detection of this model being run in 2 different processes, but on the same image. inference server will intelligently do those operations in parallel. So for example, like if you build like an ensembler that's like, hey, image comes in and I want to run model 1, 2, 3, and 4 on that image, and only output an alert if 3 of the 4 agree. If there's 3 of 4 ensembler agreement.
Right.
Inference will say, okay, great, I'm going to run rather like if I wrote that just, initially, I'd probably just write code to do that serially, where for the first one we call, then the second, and the third, and the fourth. Inference will actually see that those things can be run in parallel and give you the 4x speed up, as long as the hardware you're running on will do it. But the way that happens is all of the JSON, which is each of these are defining the inputs and outputs of what we see here. And those inputs and outputs, so each of these refers to a node, as well as what is ultimately going to be passed to the execution engine to determine the order in which these blocks operate. To your question, this JSON here can and probably will be passed someday to an LLM, where I could say, build me a workflow that detects small objects. And then
and the LLM you basically outputs this JSON, and then you're done, right? And that's for simple tasks. I mean, depends on what kind of complexity you want to handle, but for simple tasks, it is completely doable, right? It is completely it's very nicely done.
So I thought I'd maybe like speed run through a few other like fun workflows that might be fun to share. One that is pretty common is folks will do like model comparisons. So this is a YOLO model comparer, for example. So I'm going to run an image through nano, small, medium, large, and extra large. And then I'm going to do bounding box visualization for each of those, and then I'm going to show each of them. And so this is an easy way
I love
for
that.
someone to very quickly see which size of YOLO model should I use for my problem.
Yeah, is the lower calorie one good enough for my purposes? I love this.
Exactly. So I'm going to drop that one into the chat. I know that the compute
So how many startups did you kill with this this application?
How many companies have you Sherlocked?
Or
actually, how many startups can exist now that couldn't before?
Oh, good one. Good
there
one.
you go. That a boy.
I was hoping that you would have that exact answer. That's the right answer.
I mean,
and that's
if it's this, I mean, Roboflow has always been on the mission to make it be as simple as possible to add the sense of sight to given software applications. So if there's anything that we can do to enable engineers to very quickly pull, hey, I want to pull in and see which YOLO model, which capability that I can take, deploy, and use into my products. We want folks to be able to do that quickly and easily. So here's like the comparison one. Now I want to note something about the comparison one. I think you'll probably want to run you probably want to connect to your local host, because I think it takes enough compute where it may time out the hosted API if everyone on this call hits it at the same time.
All right, let's everybody try to break Roboflow now.
which I mean, we'll be adding more free compute to stuff like this, so that more obviously folks can try out and see things. But we're aiming to do our best to keep up with demand. Here's another simple one. This one is a background remover. An input image is going to come in, polygon is going to go around it, background visualization, and then similarly, we can see what an object detector would look like. So the top one here is going to do background color visualization. And so here I have some puppies that we're going to run through the background remover, if you will. So we get both the bounding box predictions, as well as the polygon. And if I show the visual, there we go. So for example, if I did the background remove from a bounding box perspective, I still get the boxes around them, right? And if I do around segmentation, I get this one. I can do a SAM2. Oh, I should drop that one in the chat. Sorry. This is an embed link.
Yeah, this is great.
A SAM2 one. This one I will note requires dedicated GPU to run. Just like I mentioned, having the hosted experience be really easy is important to us, and also sometimes especially compute intensive. So if I try to run this preview, I don't think it's going to let me, because it'll say the compute or it's not going to be happy with the amount of compute that, yeah, so I need to add some compute. But let me just talk through this. This is going to do object detection with Cocoa. Then it's going to do SAM on those detections, right? So we're going to take the boxes and then just use those as prompts to SAM2. Then we're going to visualize the halo and the other one. So that's what this guy does. And actually, let me why don't I run that in a space?
Use your special founder override key.
Yeah, I think I have a dedicated deployment stood up. So I'll call this Phil GPU.
Hey, that's my name.
That's you. That's the Phil GPU.
Aw.
Here, I'm creating. So what's happening now? So I am, from that one click, I'm provisioning my own Phil GPU. And just from the press of that button, a GPU is being provisioned for me and being built that's going to run the inference server on that GPU. It's going to be live for about 3 hours. I can always extend it and refresh it. And it's going to run inference version 18.1, which is the current release. So while that gets provisioned, why don't we show a few other maybe fun ones? I'll jump back to some of my ones in this. Yeah, Phil too. So let's license plate reading is a pretty common task that folks like to do. So this one I like because it's going to use OpenAI, right? So this one's going to use object detection and multimodal models. So what's going to happen? An input image is going to come. I need an OpenAI key as my input. And I'm going to get an upload from one of my target projects in Roboflow. I'm going to run just a simple Cocoa model. I'm going to visualize all of those things as a first thing. The next thing I'm going to do is I'm going to crop to the car region. So I use a dynamic crop block. Then within that cropped area, I'm going to run a license model that's going to look for within the car, look for the license plate. Then I'm going to crop down to just the license plate and hit the OpenAI API and say, the prompt I'm going to give it is extract the license plate text, return just the value. And then the last thing I'm going to do is continue if cars are detected. I'm going to do a dataset upload block to put this back into one of my other Roboflow projects. And let's see if I've got a car that I can run this on. Oh, I don't have, let me do a car in parking lots. Image, sorry, not having an example. Ooh. License plate. Let's try that guy out. Sorry for not having that one. Car LP. And assuming that I've got my OpenAI key. Oh, our other GPU is out of the oven, so we'll go back there in a second. Okay, so assuming that I've got enough credits to my OpenAI key, I should be happy. Oh, no, I don't. So I'll have to add some credits to my OpenAI key.
Damn you, Altman.
That's on me. That's on me.
Come on, man. You stole most of our name and you're not giving us enough credits. Come on, guy.
Well, the thing I do want to visualize here is the power of using object detection in tandem with large models. So right. I will share the embed link for that one.
So people will be able to put their own API key and try it out. All right.
Yeah.
So now, okay, so this is great for people who are building things, right? What about people who want to deploy their models so that other users on the system can use it? Just like OpenAI, right? What is the way to get into your system as a provider of technology?
So you're saying like, I want to have, I've built a model and I want to be available. So because this is all built on inference, making a PR to inference, making a pull request to the inference server, this open source project here, adds to the registry of models that users can select and build from in the workflow builder. And so, in fact, we've already seen this. The YOLO V10 authors made a PR to have it included in inference. And so you can build with YOLO v10 directly in workflows and the entirety of the rest of the places that you might want to use the open source inference server. And so any block that folks want to PR, which by the way, you can do custom code blocks too, right? So like, let's imagine that I had like some pretty specific code that I want to drop down into for a given stage. I could write a Python script. Like one of these blocks could actually just execute a Python script.
And it just needs some JSON reference. What is the input output kind of thing?
You'll declare, when you declare a block, you'll declare a JSON node, but then what is contained and what gets executed could be a custom Python script. And so that's where like a user could say, I'm expecting an image. I'm going to run a Python script that does, I don't know, sift or template matching or my own custom model. And then I'm going to write the output to somewhere else. And so that's fully supported. So one thing that kind of makes me bristle is it's like, oh, I'm a developer. I know how to write code. Excellent. Then this is an amazing prototype, build with it, plus deploy capability, right? So like the way I should spend time is incorporating this into my systems. And I want to very quickly get something in production. And just because things are easily visualized doesn't mean they're not optimized. In fact, the opposite. A lot of the optimizations here, doing things in parallel, making it easy to create and go. And these are built with the intent of being deployable on build, right? It's not like this is just a try it out. It's like I could take this, hit this as the API, and away I go.
That's awesome. Okay, so with the pull request, it means that you guys will check who's submitting this pull request and whether they are credible or not. So it's not like a general marketplace where it's all anybody can put whatever. It is kind of verified by you. All the models
it's just more curated, it sounds like.
Well, so what we currently, but what we anticipate doing is having community supported blocks. And then Roboflow supported blocks. So if we merge one, well, the community can still merge ones. We just know that sometimes projects this is the benefit, sometimes the downside of open source. Sometimes projects are not always continuously maintained. And we want to say, if it's Roboflow supported, we're going to maintain it. And if we're not going to maintain it, we're going to give deprecation notices and so forth. If it's community maintained, then it's dependent upon the author of that block. And many community projects like OpenCV continue to, of course, flourish. And then some community projects, it kind of depends. It's like they may go and then they reach a point of they accomplish the goal and they don't continue to iterate.
There's a reason we have OpenCV contrib. It's
So we'll very clearly delineate between. So if you open one that's a PR to inference, right now we only have the concept of Roboflow supported. So we'll help authors review the PR, contribute, and then merge it to main. And then we'll soon have the ability for like community contributed blocks. Which one thing I would know, by the way, is if you develop on localhost, like if I use localhost, I can write all my own blocks without doing any PRs at all. I can just add my own block to this capability, which maybe is something I can follow up with in a future.
Well, what I'm thinking is that for this is amazing, right? And if people who are building technology and don't want to build infrastructure, right? Like we train a lot of models, right? And some of them are for our clients, and some of them are for just we train it to understand about some data sets and things like that. And they are very high quality models, right? But we don't always want to give it away for free, right? Sometimes we would like to monetize it. So in that case, you're saying that let's say we create our own service, then let's say OpenCV 7 cents, right? It has a face recognition API. And if we do a pull request through that, then people should be able to input their API key, right? The 7 cents API key, and use it just like this, right?
Exactly. I mean, if the model's behind an API, then it continues to be commercial. It's just like the OpenAI workflow that we showed, where I can hit the OpenAI model, but I unfortunately don't have the maybe fortunately, unfortunately, I don't own I don't have that. That's not my model to own.
Right.
Now, of course, something that's really interesting with workflows is maybe at some point I want to swap that out to a model I could run fully offline. So I want to
Yeah.
swap out the OpenAI step here for Florence too. I
Right.
could think about doing that. But yeah, I mean, a lot of providers. So for example, if you had 7cents, there could be a 7cents block that asks the user to put in their 7cents API key. And then
Right.
yeah, and then boom, like
So
7cents model is
Mhm.
available.
So how is the naming done in that case? Let's say we have you have a face recognition block. Do you have a?
Not yet, actually.
Okay. So let's say there's a collision, right? There are two object detectors which do pretty much the same thing.
We're back to naming things.
Right. So how would that work?
So in fact, we have a few different ways of handling. So maybe why don't I go to if I just go create a new workflow. So when I go to add a model, the model names here. So these ones are just named after models that are in my workspace.
Right.
And then public models are contributed based on IDs that folks PR to inference. So for example, like right now we have an alias for this to point to the Cocoa model. So this is
Right.
pointing to a Cocoa model. But this actually goes by, I forget the full name of what that model is, but it's a much longer alphanumeric model. And so
Got it.
folks can both have aliases to their models
Yeah.
or can say, hey, look for the 7cents one
Yeah.
model. And so that's kind of like what you see here is like in my workspace, for example, I've trained corn kernels multiple times. So I have corn kernels V1 and corn kernels V3.
Right.
So and you'll see here that it gets in Roboflow, what we do is we default append kind of a alphanumeric string for keeping some independence, but the first portion is still the name of the project.
Got it.
I think I just bit through my tongue trying not to make a joke about Iowa.
I call corn kernels for your benefit.
Um,
So yeah, I mean, maybe what they want to do is like maybe they want to call it like base 7cents,
Yeah.
and then all users can go and away they go. Or if you upload your model to, if you upload your model to today, if you create a public project on Roboflow and you upload the model to Universe, I can pull in that public model here.
Right.
And so, I don't know, this UPS, I don't know, this UPS YOLO V9 model. Let's see.
Fascinating.
I'm gonna copy the name of that and drop that in. Boom. I'm now using this UPS truck finding model.
Super slick.
Got it.
And
Now, let's say we have a collision, for example, background removal, right? Let's say we have a product background removal, right? It works very well it's not general purpose, but it works very well for products, right? Let's say you want to display products, right? In that case, it is basically on a first come, first serve basis, right? We could pick a name, and if that name is not already taken, then we get it, right?
Yep.
Okay.
Yep. And so adding those to a public project will be named accordingly. Yep. So for one of these, I mean, I just grabbed this. So why don't I don't know, I'll like screenshot this and just for the sake of example to show, hey, I went to Universe, I found a model that was interesting.
Yeah.
It was called UPS merge. And now I want to run a preview on this this example. Boom. And now I could deploy this. I could run it, on a video on my video camera. And then also I could, I'll share this with the audience too. Like, hey, great, we just grabbed a publicly available model. So in other words, I can add currently supported models. If I create a public project on Universe, anyone else can find and add that just like I did here. But if there's a model architecture like task type that's not supported altogether, then I can drop down into inference and make a PR. So let's say there's like an architecture that's not supported that I want to be supported. Like maybe I want to make like a Gemini Flash block. Gemini Flash is not yet supported, but I could contribute a Gemini Flash PR, and then it would show up as a, in this case, Roboflow supported one that I could add as a different node. So I could either, add a upload my model to a public project on Universe, and then it's available, or if I'm supporting a net new architecture that I can't currently upload to Universe in a public project, then I can make it.
Got it.
Very cool. Well, fellas, we are almost 10 minutes past the hour.
Oh, wow.
All
Sorry.
right.
It's all good. We were just vibing super hard on this kick-ass new product from Roboflow. Yeah, folks, I think now is a great time to do our giveaway. For those of you that stuck around, almost everybody did. Actually, this episode we had a big shout out to the folks on LinkedIn, watching on LinkedIn. I posted on there that I mentioned that, LinkedIn seems like they're kind of not sharing our events as much as they used to on their algorithm. And I asked folks to share the LinkedIn event, and 10 people, like bam, bam. So we almost doubled our LinkedIn viewers because of the community there. So thanks so much, everybody, for that. What an awesome presentation. Super, so just game-changing tech every single time you show up, Joseph. We really do appreciate it. Folks, if you need a reminder, or if this is your first time watching, one of the things we do here on OpenCV Live is a giveaway to you in the audience. Here in the Zoom chat, I will be asking a trivia question, and you will answer. The first person to answer the trivia question correctly in the Zoom chat will win the OpenCV course of their choosing. You can go to opencv.org/university to see what courses are on offer. If you have won in the last couple of months, please do not answer and give someone else a chance to win. I have a feeling this is going to be a super easy one. We talked a little bit earlier about Joseph's favorite data set. Please give me the full title of that data set, not just the abbreviation. What do the four letters stand for in that data set? Full name.
Full name.
Yeah, see, you're all behind. Oh, you're close. Martha's close there. There we go. SRI. Okay. Correct. The answer we were looking for there was Common Objects in Context, COCO. Congratulations. Please send exactly one email to phil@opencv.org, and with the name of the course you would like. Like I said, you can go to opencv.org/university to see the courses. If you see one that you like, send me one email, SRI, and I will make sure that you get that course. The OpenCV courses support team will lickety-split assign that to you. Yeah, we've got the RF100 here. Let me just pull up you want to pull up a screen share, Joseph, and do like 2 minutes of these links you're dropping? Because I think people want to see them.
Yeah, absolutely. Real quick. So oops, wrong desktop. The joke is maybe not the joke. The one of the things that Roboflow has enabled the community to identify is COCO is common objects in context. All the things people are building with Roboflow tends to be sometimes on common objects out of context is the joke. And so what we've been able to do and published at CVPR last year was a basket of 100 data sets, which we called RF100, which contains a little over 200,000 images across a basket of 100 data sets in 7 major imagery domains. In total, the community spent a little over 11,000 hours preparing and labeling data. And so, for example, here's like an embedded view of those. You see things like aerial views of robotics projects. You see book selections. I know in this region over here of the RF100, we have like plants and agriculture. We have like cells and biology-based things. I know there's like documents, I think, up here. In this neighborhood, we have like kind of outdoor construction scenes. Over here, we have kind of traffic. Video games was well represented, like digital scenes. The point of publishing this, by the way, was to enable researchers to better benchmark how well do models generalize to novel domains. And something that's really encouraging, actually, is we're increasingly seeing Apple or teams like Apple Research and others benchmarking on RF100. So for example,
Pretty cool.
Apple published this paper using generative techniques to increase data set representation using generative data, and they wanted to measure how well do we adapt to novel domains. And so they used RF100 as an example of how well do they adapt with their technique called ODGen versus other techniques to these novel domains. So in other words, when you build with Roboflow, when you contribute to the community's public data sets or repositories, you are advancing the state of the art of computer vision. And so if anything, it's a really awesome opportunity to thank the 100 unique authors that have created, contributed, and shared a lot of their work so that we all can move the community forward. So this is paired up with Coco, and it's why I take a lot of inspiration from community projects to be able to enable the community to move forward. Thanks, Phil, for letting me share that.
Yeah, super awesome stuff. I think, I mean, we had a couple of questions here, but if folks have questions that we didn't get to here on the show during the presentation, Joseph, where is the best way for them to contact you and or Roboflow to get those questions answered?
You can find me, joseph.nelson@roboflow.com. The place that I tend to be pretty responsive is also on Twitter or X or whatever it is these days. So I dropped that link in the chat.
We'll just keep calling it Twitter here. Yes, thanks for that. Joseph of Iowa. Yes, I guess that about wraps her up for us this week. Doc, you want to take us home?
Yeah, thank you so much, Joseph. This was an excellent presentation. I mean, I loved it, and we'll talk again in a little bit more about this. Thank you so much for the presentation. As always, it was excellent, very informative, very useful for our audience. And thank you, Phil, for organizing the show. And I want to thank our audience again. You are a very, very impressive audience. Show up almost every week whenever we host the show. And it's a pleasure to have these webinars for you.
Absolutely. And some of them show up even when we're not here. I get emails. Thanks so much, everybody, for watching. Take care of yourself out there. Take care of somebody else if you can, and have a great day wherever you may be. We'll see you next week.
All right.